Hello, I'm Richard Hooper and this is SatTV News. The aviation and aerospace industries converged on the town of Farnborough in the UK this week for the world-famous airshow. With 1,500 exhibitors from 39 different countries, the show was as popular as ever despite the after-effects of the global recession. These numbers are indicative of the respect that Farnborough has established since its inception in 1948. A huge 3,600 tonnes of temporary structures are transported to the show site, and approximately 6,000 contractors helped to create the stands, chalets and company facilities. Satellite communications have become increasingly recognised for their robustness, reliability and provision of mission-critical communications, and flexibility, especially for military airborne communications. Governments all over the world are procuring SATCOM systems and services to help them meet their civil and military objectives. SATCOM can support communications in a wide range of frequency bands and high data rates, supporting voice, data, internet and video applications. These systems are fast becoming an integral part of communications in the government, military and commercial arenas, and they are also an integral part of the Farnborough Airshow itself. EADS Astrium launched its airborne terminal, AirPatrol, designed to provide end users with a lightweight, high-performance communications module, capable of operating in the most demanding conditions. Developed by Astrium Services Secure Satcom Systems, which has over 25 years of experience in the design, manufacture, installation and maintenance of advanced Satcom terminals, AirPatrol is compatible with all types of aircraft, including unmanned aerial vehicles. I took the opportunity to speak to Aidan Joy, Director of Secure Satcom Systems at EADS, about the new AirPatrol terminal. Now Aidan, you've just launched the AirPatrol terminal. Can you tell me a little bit more about it?
Yeah, hi there, Richard. Yes, we're very pleased to be here at Farnborough this week launching our new terminal. The AirPatrol terminal is our third generation now of satellite communication terminal for airborne applications. It's a modular terminal that we've developed for a variety of different programs and applications. It's designed using carbon fibre composite materials, which gives us some excellent performance. We've introduced software-defined radio techniques to make sure it's scalable and upgradable for different applications. We're using gallium nitride technology, all of which combined with some of the innovative engineering techniques that the Astrium engineers have used gives us a really exceptional terminal which we think the market is going to like.
Now, who are the main customers for the terminal?
We've developed this with a number of different customers in mind. We've ensured that what we've got is a modular terminal, so it can be used for a variety of either UAV programs or fixed wing or even indeed rotary wing programs. So we've ensured that what we've got is a terminal that we can use for a whole variety of different applications, and we're talking now to a number of different programs, both for new build and for different legacy programs for upgrade of different platforms.
Now, it's designed with a 30-year life cycle. What's the reason behind that?
Well, clearly, it's always been the case that through life support costs have been very important. Designing it with a long life ensures that we can, particularly with our capability to upgrade the platform as we go through its life, it gives us a very low total cost of ownership, which is clearly even more important today in the budget-constrained environment that we're working in.
Now, it's got an interesting stabilisation system in there. Is that a third-party stabilisation system, or is it designed by Astrium?
No, that's designed by Astrium. That certainly uses a lot of our heritage that we've developed over the years, both in airborne applications and naval applications, where the stabilisation of a moving platform to ensure that we keep reliable links onto the satellite is so vitally important. And it's even more important today as we move to some of the KA band applications, where the pointing accuracy that's needed is so important. And it's certainly one of the areas that the Astrium engineering skills are brought to good effect.
Now, what other design innovations are actually in the terminal? I know it's built using carbon composites. What other things are actually there that make it so, interesting?
Yeah, well, as I mentioned earlier, we've used gallium nitride techniques and for some of the RF components. The use of carbon fibre is very much an integral part of it, both in terms of keeping the weight down and ensuring that we get good RF performance from the dish itself. And we've adopted software-defined radio techniques in some of the baseband equipment, the modem, so that we can ensure that the system can be upgraded over the air for new waveforms, which gives a lot of extra flexibility and again improves the ease of maintenance through life, again keeping the cost of ownership down for the end user.
Aidan, thanks for your time.
Okay, thank you very much.